Okay, welcome back, kiddos. Now we're talking about Unit 2. So we're going to talk about statements and proofs. So let's first start with some um, explanations. So, what does conditional mean? Conditional, what that means is depends on certain conditions taking place. Okay, so that's exactly what conditional means. It depends on certain conditions taking place. Okay, so we're going to talk about two terms here. The first one is going to be hypothesis. Okay, so the hypothesis is the if statement. If statement. Statement. Okay, and then we're going to talk about conclusion, which is the then statement. Okay, so we said it's under certain conditions. So if something happens, then something happens. So um, let's get right into writing a conditional statement. So we're going to let the hypothesis, which we said is the if statement, be snow is falling. So we're going to say if, because that's our hypothesis, if snow is falling, and our conclusion is it is winter. We said that's going to be the then statement. So then it is winter. Okay, so that's what we want to key in on. The hypothesis is the if statement. Okay, the conclusion is the then statement. Okay, so if snow is falling, then it is winter. Okay, so that's what we call a conditional statement. If this condition is happening, then that is true. Okay, so let's keep going. All right, so let's look at this. It says, what is the hypothesis? Okay, we said hypothesis is labeled by P, and the conclusion, which we said is labeled by Q, in this conditional statement. So instead of hypothesis, we're just going to say P. Okay, instead of conclusion, we're just going to say Q. All right, so what's the hypothesis and conclusion in this conditional statement? So the conditional statement is this: if you liked it, then you should have put a ring on it. So what's the hypothesis? We said the hypothesis is after the if. So if you liked it, so that's going to be the P, is going to be the hypothesis. You liked it. Okay? Then the Q, which is a confused conclusion, comes after then, right? So we want that to be the then statement, and the hypothesis is the if statement. Okay? So if you liked it, then you should have put a ring on it. Should have put a ring on it. Should have put a ring on it. Okay, so the hypothesis comes after if. Okay, and then the conclusion comes after then. And that's how we do it. So here's the basic structure that we're going to talk about. So if P, then Q. Okay, so if the hypothesis, then the Q. Okay, so is this true or false? If you liked it, then you should have put a ring on it. Is that true or false? That is true. If you liked it, you should have put a ring on it. All right, next we have converse. Okay, so the converse, these are the vocabulary words you need to talk about. So the converse, we talked about conditional. Converse means we switch the hypothesis and the conclusion. So we're going to swap them. So we're just going to switch the order. So we're going to say if you should have put a ring on it, we're going to put that first. So if you should have put a ring on it, then you liked it. Okay, so if you see that, all we did was switch the order, switch the hypothesis and conclusion. So if you should have put a ring on it, then you liked it. So the basic structure, instead of if P then Q, we said we switched them, right? So it's if Q then P. Okay, so let's see if that's true. If you should have put a ring on it, then you liked it. Okay, Well, yeah, you wouldn't have if you didn't. So if you should have put a ring on it, then you should have liked it. That's true. All right, next, inverse. Okay, inverse means negate the hypothesis and conclusion. So what does negate mean? Negate means not. Okay, so we put not in front of it. So it means you don't do it, right? So negate not the hypothesis and not the conclusion. So if you didn't like it, if you did not like it, then you should not have put a ring on it. You should have not put a ring on it. Okay, so that's our structure. We're just going to negate both of them in the same order. So we're going to negate both in the same order. So basically, we're going to say if not P, then not Q, right? Because so we said it's the same order as this except for adding a not in front of it. If not P, then not Q. So if you did not like it, then you should not have put a ring on it. That's true too. If you don't like it, you shouldn't put a ring on it. Okay, next, contrapositive. So I know these are a lot of weird words, but that's okay. Contrapositive. Switch and negate the hypothesis and conclusion. So we're going to switch them and negate them both. Okay, so let's switch and negate. So we're going to put this in the first and negate it. So if you should not have put a ring on it, right? If you should not have put a ring on it, then we said we're going to say or swap it and negate it. Then you should have not liked it. Then you should have not liked it. Right? So if you should not have put a ring on it, then you should not have liked it. So we swap the order and we negate it. So if not Q, then not P, right? We swapped the order and we negated it. So let's see if that's true or not. If you should not have put a ring on it, then you should have not liked it. Yeah, if you shouldn't have put a ring on it, then you shouldn't have liked it. That's true. All right, then the last one, biconditional. You take out if and then. So you take out if and then. Okay? And you put if and only if in the middle. Okay, so we take out the if and we take out the then. So we take out the if and we take out the then. So you like it, you liked it, and we took out the then. So you should have put a ring on it. You should have put a ring on it. Okay, and then we said we're going to put if and only if in the middle. I'm just going to put it a different color. If and only if. Okay, so if and only if goes in the middle. So you liked it. If and only if you should have put a ring on it. So P, right? If and only if Q. Okay, so you liked it. If and only if you should have put a ring on it. So does that make sense? You liked it only if you should have put a ring on it. Okay. You could have liked it if you shouldn't have put a ring on it, right? You still could have liked it. But so that's not necessarily true. That is false. Okay, so I know this can be kind of confusing since it's the first day, but that's what we're going to think about. Okay, hypothesis comes first with the if statement. That's going to be P. Conclusion comes after then. That's going to be Q. So conditional, you say in that order. Converse, you switch the order. Okay, if Q, then P. Inverse, you negate them in the same order. So if not P, then not Q. Contrapositive means you switch and negate. So if not Q, then not P. Biconditional, you take out if and then, and you put if and only if. So P, if and only if Q. All right, so thinking about that, let's try to apply it with some geometry so far. Okay, so it says decide whether each statement about this diagram is true. Explain your answers using definitions you have learned. Ooh, okay, so let's take a look at this. All right, so this first one, this says this, this. Okay, let's read this out. This means line AC. Okay, so let's pronounce that. Line AC. Okay, this means perpendicular to. Okay, line C is perpendicular to line BD. Okay, so we're seeing, is that a true statement or not? Line AC is perpendicular to BD. Well, what does perpendicular mean? Okay, perpendicular means makes a right angle. Okay, so that's what that means. So let's take a look. It says AC and BD. So let's kind of trace those out real quick. Let's change the little color. AC is this right here, right? And BD is that right there. Okay, so we have two lines that cross. What does this tell us? That tells us it's a 90-degree angle, right? So what's our statement? We would say true. Why? Because of this symbol. Right? Because of that symbol right there that told us that it was. Okay, next. Angle AEB and angle CEB are a linear pair. Okay, so let's take a look at that. AEB is this right here, right? And CEB. Let's draw that out real quick. That's A, that's E, that's C, and that's B. It's asking, is this a linear pair? And the answer is yes. It is a linear pair. That's true, right? Because this right here and this right here are opposite rays, right? EA, because, I'm sorry, EA, we can say ray EA and ray EC are opposite rays. Okay, because EA and EC are opposite rays. EA and EC are opposite rays. That's true. All right, let's look at our last one. Ray EA and ray EB are opposite rays. Okay, remember, opposite means they go different directions on the same line. Okay, so let's look at EA and EB. EA and EB. They're asking, are they opposite rays? And that's false. Right? Because one's going one way, right? And one's going the other way. That's not opposite. Not opposite. All right, so that's our answer. All right, so we're going to be practicing this in the next few days. So right now, go to your Delta Math and your practice between converse, inverse, contrapositive, and conditional statements. Okay, so if you have any questions on these, just let me know.